Kia ora, Year 12. This video is going to go through some questions from 2018 and 2019 that use surds and fractional powers. Yesterday I did the more recent questions, and these older ones are a little bit easier. They're a lot like the kind of early questions you'll find in the Walker workbook or in the theta textbook. All of them in here, except for this one I've put in green, are achieved questions, and the one in green is a merit level question. Okay, so let's just start from the start. So when I see something like this, 9a squared b to the negative 4 to the power of 0.5, I just remember the rule that if I've got a number, say I've got 5x squared to the power of 3, then that's going to be 5 cubed times x to the power of 2 3s are 6. So I'm going to multiply these powers when I'm working with variables, but I do the powering when I've got the number. And if you look at one of my Year 9 algebra videos, you can see why that works. In this video, I'm assuming that you're pretty confident with that idea. So here we've got 9 to the power of 0.5, which is the same as the square root of 9. And then I've got a squared to the power of 0.5, so that's going to be a to the power of 2 times 0.5 times b to the power of negative 4 times 0.5. Now, you don't have to write it out in that much detail, but it will probably stop you from making little mistakes when you're revising for November. So it's going to be 3a b to the negative 2, and we should write that with positive indices. So that will be 3a over b squared, right? Because b to the power of negative 2 is equal to 1 over b squared. Right. If you're not confident with that, go and search up my video on working with negative powers. So that's that question done, and that's a little achieved question. The next one is similar. We have to simplify this and leave our answer with positive indices. Okay, so 2a over 3b to the power of 4 to the negative 2 is equal to 3b to the power of 4 over 2a to the power of positive 2, right, because of how negative powers work. Remember that if I've got a to the negative 5, that's equal to 1 over a to the 5. Right, so working through this, that gives me 9b to the power of 8 divided by 2 squared is 4. So that's my final answer for that one there. Okay. You could have done that one a slower way if you're really unconfident with negative powers. I'd like to see everyone in my class doing it like this, just knowing that when I've got a negative power, it means the reciprocal to the positive power. But I could have done this, right? I could have gone 2 to the negative 2, a to the negative 2, 3 to the negative 2, b to the negative 8. And then from there, we could have done 2 over 2, this is very slow, right? But this is what we're actually doing, is 1/4 times 1 over a squared divided by 1/9 times 1 over b to the 8. So I'm going to work this through, but hopefully you're seeing that, this is a pretty inefficient way to do this question. So it's well worth getting confident with the negative powers so that we don't have to think like this. So in the numerator, I've got 1 over 4a squared, and in the denominator, I've got 1 over 9b to the power of 8. And we know that when we divide by a fraction, that's the same as multiplying by the reciprocal. So we end up here again with the correct answer, but with a whole lot more work. Okay. All right, on to the next couple of questions. Let's see what we've got left. Okay, question 2018 paper, there were quite a few in here. The first one was to simplify this. So this is equal to, I'll go really slowly, 25 to the power of 1/2 times m to the power of 16 times 1/2. Now, anything to the power of 1/2 is the same as the square root of that number. So it's the square root of 25 times m to the power of 8, which gives me 5m to the power of 8. And you'll see that this question here, 2018 question 1b, is very, very similar to 2019. It's checking that we understand negative powers. So this time it's a little bit easier. We've got 4 over 3a to the power of negative 2. That's the same as 3a divided by 4 to the power of 2, which gives me 9a squared over 16. Right, one question left, and that's this one here. So find an expression for x in terms of w if this equation is true. That's another way of saying make x the subject. So we're going to do some rearranging. Now, when I look at this, here's what I see. I look at the bases, and I see that here I've got a base of 3, here I've got a base of 9, and here I've got a base of 27. So the first thing I'm going to do is to get everything to have the same base. Just get rid of that old working from yesterday's video. And the base here that I'm going to work with is 3. So I'm going to have 3 to the power of 4x plus 1, but instead of 9, I'm going to have 3 squared to the power of x. And instead of 27, I'm going to have 3 cubed to the power of w on 3. Now, working really slowly again, here, this gives me 3 to the power of 4x plus 1 divided by 3 to the power of 2x. And here, this is going to equal 3 to the power of 3 times w over 3. And I can simplify quite a lot here. I've got the same base here now, so that means I can subtract these powers, giving me 3 to the 4x plus 1 minus 2x. And on this side, I've got 3 to the power of w. That gives me 3 to the power of 2x plus 1 equals 3 to the power of w. Now, the bases are the same, which means that for these two things to be equal, the powers must be the same. So I can simply write down 2x plus 1 equals w, and now our goal is to get x as the subject. So we have 2x equals w minus 1. Finally, we have x is equal to w minus 1 divided by 2. It's fine to leave it like that. It's also correct to write it as w over 2 minus 1/2. Okay, thanks for watching. Email me if there are any other topics you want me to do in this format. Otherwise, I'll just keep on going back through some of the older questions.